Well, it looks like we can officially start. Welcome back, everyone. Usually when you come to class, I'm going to have lots of weird doodles on the Moodle webpage like this, just giving out announcements, saying where we're currently at, maybe just some formulas for review, things like that. The unfortunate thing is, once I jump into the notes, all that has to go. It's just, you can't make heads or tails of what's happening. But one thing I want to promise you is that I'm never going to put information here that can be found nowhere else. So if there's a formula, it's probably in the notes and we're just previewing it, for example. You bet. That'd be rude to just delete stuff forever all the time. So everything here, although it's temporary, it's always found elsewhere. Well, before we get started then, folks, any questions at the moment? Okay, well, we didn't do a whole lot. Oh, sorry, go ahead. For today, no, you should be okay. I would say calculators are most likely to start coming up once we're into, say, chapter 2, definitely chapter 3 and beyond. But always good to have it. It's a good thing to be ready with, especially since when we go to take, say, exam 2, there's going to be more calculator stuff. And just knowing how to navigate it, what buttons to press is part of the exam as well. So the more you can just do things along with me, whether you're just calculating the buttons or stuff like that, it really will help later on during times of when the final exam comes down. Well, other than that, I'd say maybe another announcement is we didn't get too far last time. We just did the first topics in section 1.2, talked a lot about WebAssign. And it looks like most of the class is already registered. Some have completed homework assignments, which is awesome. And so I'll just leave it up to the class. Any questions about WebAssigns, concerns, or comments that you may have? Okay. Sounds like things are going too bad so far. If you haven't explored too much around the system, just keep in mind that if you ever have a hang up on there, never hesitate to email me. I'll always be very happy to help out. As far as due dates go, they're going to appear in a couple places. They're always going to be apparent in WebAssign. I also put them in Moodle as well, just so that they're apparent. There's kind of a purpose to that as well. If you see a due date suddenly showed up, that means there's an associated assignment in WebAssign. And it also means I'll probably be finishing section 1.2 today, hence the due date. We might finish section 1.3 and it'll be due a week away again if we do. If we finish it tomorrow, it'll be due a week away from tomorrow as well. So if you go into WebAssign for just a quick peek, this is what you're going to be taking a look at once you get in. And notice I have to put due dates somewhere, but the only ones that are official are the ones you see in Moodle. If we take maybe an extra day in 1.4, I'm just going to move the due date an extra day. So think of Moodle where the information is official, and here there's some fluctuation that can happen. Another thing I want to mention is the due dates are largely for pacing, so that we're working at a reasonable pace to absorb the material for the final exam. If one of these sections goes past due, you can request an extension at no penalty. So as long as you get to those topics and get them finished off, then you're going to be in great shape. Well, any questions at all then, folks, about WebAssign or otherwise before we jump back in? Okay, I'm going to talk a little bit more about extensions, but that's probably better done once one of these goes past due. Just for a quick preview on it, it's really just right here, request an extension. It's done on the student side, so once you do that, I just go in and put the extension. And we'll talk about it a lot more once again, one of these goes past due. Well, we're back to section 1.2. After we complete this, we're well on our way to run through chapter 1. We'll probably be finished with chapter 1 sometime next week, depending on where we end up. So now in 1.2, really we only looked at two definitions, what we mean by a population, what we mean by a sample. This is a really terse description of what is said here. But we're also using that opportunity to kind of illustrate what we're really going to be doing in the course. So here's a typical population, here's a typical sample, and the various things we might measure, like sample means to try to estimate the population means like mu. But let's turn it now to a new example. And again, when you see all this, it's really pretty rough. There is a lot of reading in a statistics class. All the problems, like we mentioned before, turn out to be word problems. But if you know what you're looking for, they're not so bad. At WebAssign, it's certainly not terrible since it's all multiple choice. But I want to mention once again, we have to get used to the idea of that's where the problems are a little bit easier since you have a list to select from. Once they come in as a quiz, any one of these problems, That's where it's a little bit different. The quizzes won't be multiple choice. We have to know how to write the answers on our own. So this is our opportunity to practice this right here on example 1. First, we have a couple technical definitions to get through: an observational study versus an experimental design, or just an experiment for short. If you read through these definitions, maybe the first thing you want to do is find the major features that differentiate the two. We're both trying to get data, whether it's a study or an experiment, but how they get the data and what conclusions can be made from the data are massive, depending on which two we do. Our author states that the observational study, this happens when, in a study, where the person conducting the study observes characteristics of a sample selected from one or more existing populations. Well, that doesn't sound too interesting on its own, but that's essentially what was happening in our example above. This is an observational study, since we just took the 100 graduate students. We're not doing anything to them, we're just recording their GPA and taking the average of that. So that's what we would mean by an observational study. In fact, let's just add a quick note right here. This is an observational study. I'll put that in parentheses since it was an afterthought. So now the key difference from going from an observational study to an experiment is the following. Author states, in an experiment, we have a study in which the person conducting that study considers how a response behaves under different experimental conditions. Like this line right here, it says, the person carrying out the study determines who will be in each experimental group and what the experimental conditions would be. Say, instead of a study dealing with students at ISU, we could have a study dealing with, say, laboratory mice. We might give them one dosage of a drug, that'd be one treatment, a different dosage for a second treatment. Maybe some of the mice get no drug, that'd be the control group. And that's really the major difference between an observational study versus an experiment. An experiment, there is different experimental settings, and we're going to compare what happens in each one of those. Any questions or additional comments so far? Okay, well, here's our big question for this definition. We'll try another example as well. These problems are similar to what you might see in WebAssign. Let's a little bit more verbose on this one. It's a harder problem, I'd say. Also, it's not multiple choice. We have to come up with the best answer ourselves. The question is this an example of an observational study or an experiment? And now we have to read through all of that to just get a feel for which it could be. It's really par for the course in a statistics class, studying these bits of information very, very carefully. So let's run through it and see how it goes. It says the article, Baby Scientist Experiment with Everything, this was published in Wall Street Journal 2015, describes a series of studies published in the journal Science, which is a reputable journal. Here's how it went. It said, in one of these studies, 11-month-old children were assigned to one of two groups. Already, we might feel like this could be one type of study or another. I like that right there. Let me highlight that in gray. If you know that there's more than one group, it might be an experiment, but that's not a guarantee. Let's keep on reading to see if we believe it truly is. It says the children in the one group were shown a ball behaving as expected, such as rolling into a wall or falling off an edge. So that ball is just obeying physics like anyone would expect. But there's another group. The children in the other group, which was assigned to by the experimenter, were showing a ball behaving in an unexpected way, such as rolling through what appeared to be a solid wall, rolling off an edge, remaining suspended in air. So essentially, they got a magician to mess around with the mind of the baby, and this is what they did next. The children were then given a ball and another toy. The researchers found that the children in the group that saw the ball behaving as expected showed no preference for the ball over the toy. Makes sense, right? It's just an ordinary ball. But that was the first group. And in the second group, it said, the children who saw the ball behaving in an unexpected way tended to choose the ball to play with and also play with it differently. They're trying to understand just what was going on, what's happening with physics, what's happening with reality, by dropping it or rolling it. So How do folks feel about this one? Does it feel like an observational study or an experimental study? Yes. Exactly. There's two different groups. The children were placed into those two groups by the researcher trying to learn something about psychology, it looks like. Mm-hmm. Yes, one group of kids got the normal ball. The second group got the ball that was behaving differently. And that's really the essence there. If we're placing people into different experimental conditions, comparing what happens afterwards, then we definitely have an experimental design. So how could we answer this one? Well, this could be a real exam question or a quiz question, which are lower stakes. And part of what I'm wanting to do when we get started with this class is just give you an expectation of what you would need to respond as. If it says, is this an observational study or experiment? First, let's just throw in an answer. And experiment. But then always watch out for anything like this. Explain or justify your answer. Sometimes on exams, I don't even put that there. Maybe I just want you to move through the prompt quickly and just answer to move on to the next. But occasionally, I want to see what your justification is. So we just have to add something that justifies it. These don't have to be extremely verbose. You can be really, really brief, and that's just fine. Probably encouraged in an exam situation when we have just 50 minutes. So let's go back to what experimental design says we have to do. Person carrying out the study determines who will be in each group and what the conditions will be. And that's what happened here. They assign all of the babies into one or two groups and decide on the conditions. So we can conclude this one by saying an experiment since, let me try again, since the experimenter the person in charge of the study assigned the children, these were 11-month-olds, to two different experimental, let me scroll just a touch, conditions. So that would be considered a complete response, I'd say. You might add more detail to here, and sometimes on the notes we'll add a little bit of extra detail just to fill out the notes. But if this was your response on a quiz or an exam, I'd say that's terrific. Well, any questions, folks, on getting through this one? Yeah, go ahead. Absolutely, yeah. For these kind of problems, I'd really want to definitely illustrate the definitions, both of them, one example for each. But when you go to the next example, let's decide if it really is, we're expecting an observational study, right? Let's see if we can tell if it really is an observational study because it feels like an experiment. If we can't tell the difference, then we've kind of missed something between these two definitions. But first, any questions, folks? Any additional comments on this problem here? Yeah, go ahead. Exactly, yes. But the person who does the assigning, the experimenter, is the one who's in control. Say, for example, all of us are going to be put into maybe an experimental treatment of some kind. If I'm the experimenter, I can't allow people to choose which group they want to go in. That would invalidate the experimental design. It would be introducing some biases. But if I use randomization, maybe flipping a coin or maybe a six-sided die, something like that, to decide who goes into which treatments, now it's an actual experimental design. Does that make sense for that question there? Awesome. Other questions or comments? Okay, well, let's keep on going to the next one. Sometimes when I'm doing these notes, I do have a weird issue. The resolution is tiny. The screen space here is not great for trying to bump it up to 1080p. So we're on a very small resolution. So you might notice the definitions sometimes just get duplicated. That way we're not scrolling up and down when we're looking at new problems. Sorry about that if you're printing these out. The Word documents, you could delete some of this to make it smaller if you needed to. Well, here's the same definitions again, and same kind of question. Is this an observational study, or an experiment. Let's see if we can decide which is on this one. So in example 2, we're looking at an article that says, how dangerous is a day in the hospital? It sounds like it's an interesting study. This was in 2011, published in the journal Medical Care, and it describes a study to determine if the risk of an infection is related to the length of a hospital stay. And when you say that, I think a lot of people already have expectations. I would expect if I'm in the hospital for 100 days, my risk of infection is probably pretty high versus just going to the hospital for 1 day and out. But this is what the researchers actually did. They looked at many hospital patients, compared the proportions who got an infection for 2 groups of patients, those who were hospitalized overnight, that's the first group, and those who were hospitalized for more than 1 night is the second group. So we want to decide, is this an experimental design or an observational study? Any volunteers for which it could be? Yeah, go ahead. It's definitely observational. So let's start with that. This is an observational study because, and to me, this one's really kind of tricky. I really like this problem that our authors put in here. She's very good at illustrating small nuances. Anyone see why this ought to be observational? Yeah, go ahead.
The groups were not separated by the observers. They were separated just by natural causes.
Exactly. Exactly. So the person who would have liked to assign people to one group or another absolutely cannot do that, right? You can't walk into the hospital and an experimenter says, well, you are assigned to the, let's see here, more than 1 night group. That has to be done by the hospital staff. They're the one who are deciding the care. They're the ones who have the control. What we're doing with this study is just simply observing what has already happened without actually placing people into groups by random. So even though there's groups, it's all about who chose those groups. I like the way you said it. Let me know if I differ from the verbiage here. I'll say because the experimenter did not assign the patients to the different groups. So again, right here, let's see if we can find that. If the person carrying out the study determines who will be in each experimental group and what the conditions will be, to me, that's the biggest portion to highlight, with the difference between observing what's happened versus adding control and running an experimental design like here. Well, does that make sense to folks on this conclusion for this one? Excellent. So we have 2 kinds of studies. We can look into historical records or track people and just see what happens. We are dealing with observational studies, or we can gather people, patients, subjects together, assign them to different conditions. Now we're running an experimental design. Well, they're both great ways of getting data. And if we do it just right, the most important thing about it, either one of them, is this right here in orange. I guess that's violet. This is telling us if there is randomization, maybe you randomly selected the people in your observational study, or if there's randomization because people were randomly assigned to 2 different treatment groups or more, then anything we do with this data here, the sample statistics, will give a justifiably good approximation here. We just have to explain how good. So that's the need for knowing what kind of data we have and that randomization is working. But the difference between observational studies and experimental design goes even a little bit deeper than that. The conclusions we make are also extremely vital here. So before we turn off these notes, let's add a little bit extra on both of these. I'm going to leave in a digital pen our official response. I'll put in bracket here with typing just the additional details. Let's say here, suppose that the researchers found that people who are hospitalized for more than one night are more likely to have an infection, let's say on average, since they're probably going to be looking at the mean, the average values, than people who are hospitalized for just one night. So maybe that's the conclusion they did have. The data supported it. Then there's a really big danger here. Everyone in this study might have a slight temptation, unless they're very, very disciplined with this, to conclude length of stay caused the increased likelihood of infection. But that turns out to be false, unfortunately. It turns out only a controlled experiment can establish cause and effect. If this is an observational study, and it was, all they are finding is an association or a relationship between length of stay and infections. There could be many other variables that are causing infections. For example, what happened to you to bring you to the hospital? That's probably more important than how long you stayed in the hospital for some infections. So let's add here to finish off this thought. In this case, we must be very careful, since this does not show that length of stay caused more infections, since this was not a designed and controlled experiment. So that's the massive unfortunate fact about not having experimental design. And you might say, well, maybe they could fix it. Well, not really. There are some experiments you just can't run. You could never get funding, they're unethical, and saying how long people are going to stay in a hospital would be one of those. So that's an interesting study. You can still get reliable information. We're still furthering the sciences, but there are always limitations that we have to consider depending on how we even got the data. Well, any questions, folks, or comments? Okay, let's add maybe a comment just like this one to example one to finish off the notes. Example one was an experimental design. So you can say in that case, the children being exposed to the weird ball caused their inquisitive behavior and how they played with the ball later on. I'll put here just briefly, since this is an experiment, the researchers can establish cause and effect in their conclusions. So it's always really very subtle. We're going to be taking a look at more of this later on. But the actual conclusions we write after we get data, run some tests and things like that, are highly influenced by what was the study even to begin with. Well, that's the conclusion of the section 1.2 notes. Any questions or comments, folks, before we move on to the next section? Okay, one thing our author does, which I think she does a really great job, some of these sections in the book are really very small. They're just like bite-sized nuggets. Sometimes I teach this as a 75-minute class, and I might do 2 sections in one day, which sounds crazy, but these are sometimes really short. Other times the sections can be a little bit longer. It just depends where we are at in the book. Chapter 1 as a whole is a pretty short chapter. Well, I'll save this up. Next thing I'm going to do is re-upload it here with the full solutions. And now we're in section 1.3. We were just talking about observational studies, experimental design. 1.3 will focus on observational studies, and then we'll focus on experimental designs very next in section 1.4. So let me open up those notes. We have more definitions to get through, and this one is just kind of a warm-up. We saw this already in section 1.2. These notes here are a little bit longer, but not as bad. So like we remind ourselves before, when we say the population, we mean the entire collection of everyone that we're interested in studying. I think I used green from before. But if we say sample, we're just looking at a part, a subset, or just a segment of that underlying population. We need samples because studying the entire population can sometimes be extremely costly. Say, for example, if you're the US government, the Constitution says you have to conduct a census every, I forget how many years, I think it's 10. Correct me if I'm wrong on that. But that is an extremely, extremely costly endeavor. And what we mean by census is they're trying to sample the entire population. Well, billions of dollars get spent on doing that, and it's arguable what their success is in really even getting a census. When it comes to a sample done just right, you can get a remarkable amount of information extremely cheaply. Again, if it's done just right, and randomization is part of the key there. But before we go into those topics, here's our really fast example one. These numbered examples, again, they're meant to be similar to what you'll see on WebAssign. And this one is very similar, I believe. It says here, the San Fernando Valley residents okay with 1 cent transit tax, MTA poll says. Our author's from California, so some of it is California news. This was a headline of an article that appeared in LA Daily News in 2016. So they're saying here that the article claims that these residents are okay with some kind of tax on their transit system. This headline was based on responses from a sample of 100 San Fernando Valley residents. And all the instructions say is describe the sample and the population of interest for this poll. Now, even though they said sample and population, it turns out, I think in a lot of cases, it might be easier to start with one versus the other. In this particular problem, let's maybe start with the population. If you're not sure what the population might be, you might instead start with a sample. But recall the population is meant to be everybody we're interested in learning more about. Anyone see what the population ought to be for this situation?
Wouldn't it be the entirety of the San Fernando Valley? Or just the residents there, all of them?
Exactly. I like how you said all or entirety. Those are the major things to look for when you're looking at a population. Let's go with all San Fernando Valley residents. And that's pretty much it, folks. We did it. That's our population. I want to reiterate that WebAssign is a little bit tricky for these kinds of problems. It's just a computer program, and it's giving us multiple choice on this. It's a little bit easier to select the correct multiple choice than it is to come up with it from scratch like we're doing right here. So think of WebAssign as we're practicing. You found the right answer, think about why it might be right. Don't just move on to the next too long. The more you spend with those problems, just considering them, the more we're going to absorb the information to help us out down the line. If you have one, either a population or the sample, getting the other is usually a little bit quicker. So let's now say sample. The sample is just a segment of the entire population, all San Fernando Valley residents. But oftentimes it's kind of looking right at you. It said here, the headline was based on the response from a sample of 100 San Fernando Valley residents. I like the wording there because they're really just trying to give it to us. That's our sample. We can just say simply here, the 100 residents selected. Notice I was really brief on this one. I didn't specify San Fernando Valley resident, but we didn't have to because we know the sample already came from the population, meaning it would have been redundant. We already know they had to be San Fernando Valley residents. Well, that's our warm-up question for these notes. Any questions or comments, folks, about population or sample? Okay, well, let's try this out again. We're going to start building on these things, adding other terminologies, and that's kind of what chapter 1 is about. There's just lots and lots of different bits of vocabulary. And here's something we're going to be discussing a lot. Once you have a handle on population versus sample, that's a dichotomy already, and it's paired with another dichotomy, parameter versus statistic. Our author uses the word parameter interchangeably with population characteristic. Sometimes you'll see this one, other times you'll just see parameter, but think of them as being fully synonymous. So a parameter is a number that describes the entire population, whereas a statistic is some number that describes a sample. So that's a major association that we have to help our brain remember throughout the course because it comes back massively on the second half of the course, I'd say. In fact, we've already discussed parameters and statistics. Let's add a little bit extra right here above. We introduced the symbol mu when we were looking at the 1.2 notes. The mu was the average of all GPA of ISU students. That means it was a population average. So mu, which is going to be the mean of a population, is a parameter. Then when we looked at X bar, we're just studying the sample of 100 students. X bar itself is the mean of the sample, and it is a statistic. Essentially, what we're doing in this course is using the statistics, things like S bar, S, and other things, to estimate the parameters, things like mu, sigma, and other things we're going to define. The parameters are typically things that are unknown. If we did know them, there'd be no reason to do statistics. We don't have to gather random samples if we know everything about the population. So parameters are typically the unknowns, and it's the statistics that we use to estimate those parameters. Now there's one extra concept here, and that's the concept of a census. Census is a sample that includes the entire population. And this is often, in a lot of situations, pretty rare. They're very costly, like we mentioned. If you can make a census happen, it's always in your best interest. So all a census does is, the sample is itself your entire population. Let me turn to what we were looking at in the past. At 1.2, here our population was all ISU students. And I mentioned we're selecting at random 100 students to calculate the statistic X bar. Now, why would we do this? Probably because we're not affiliated with ISU. Maybe we're a rival campus and we're trying to learn more about our rival. But if the experimenter is ISU, this would never get done. They would just go to their database. They would sample every ISU student registered in the current academic year and crank out mu. It's just a computation. So in some situations, you might be able to force a census. It might mean you're in complete control of the company organization that you're working on. And so if a census can happen, then it's probably the best thing to do. Any questions about that definition so far? Okay, well, here's our example 2 to go along with them. Now, this is kind of a inflammatory title, but it came from USA Today. So that's kind of a almost tabloid type of newspaper magazine. It used to be great, but it's slid down in the past. It says here, the article, "Soldiers Hate Their Jobs," from USA Today, reported that 52% of soldiers surveyed were pessimistic about their future in the military. This statement was based on data collected in 2014 in an annual assessment that all soldiers must take each year. Some of these words are more important than others. I would say that's probably the most important word right there. All soldiers took this assessment. So let's just highlight that. I'll highlight these things in gray to say, I don't know how important they are next, but they seem important, so we'll focus on them. Now for this 2-part question, part A is asking, if the population of interest is all soldiers serving in 2014, does the group of soldiers surveyed represent a census or a sample? Anyone see which it should be? I agree, only because they said here, the population of interest is all soldiers. which makes sense. The military is not going to care much about anything else, just the people who they're working with, serving in 2014 specifically. In that annual assessment, all soldiers had to take it. So we can now assume we really have a census. Let's say here, this is a census since all soldiers were surveyed. So that's great. We have a census. And now they also reported a figure to us. They said 52% of soldiers were pessimistic about their jobs. Now we're wondering, is that 52% going to be a population characteristic or a statistic? I feel like this one's tough, but any volunteers for this one here? Yeah, go ahead. Exactly. So this one is a population characteristic. You can see why sometimes the author uses parameter. It's place of that. Since, and what would you say the justification might be for that? Kind of like a tangled loophole of jumping around, right? The way exactly when they said all soldiers took the assessment, and then they said the population of interest is all soldiers, and a census is a sample that includes the entire population, this time all soldiers. That's what's forcing this to be a population characteristic this time. Yeah, go ahead.
They interviewed like a town and only the soldiers responded, would that be a sample then? Because the population would be everyone in the town.
So you're saying you're only sampling soldiers from a specific town?
Yeah.
Yeah, in that case, we no longer have a census. The 52% would be referring to the statistic, since we just have an ordinary sample. Exactly. So yeah, this problem is written like almost perfectly, so it could result into it being a census. I'll say here, it's population characteristics since the sample is a census. Well, any questions, folks, on getting through this one here? Okay. For the moment, we have a lot of definitions already starting to stack upon each other's. We have population sample, observational study, experimental design, and now parameter versus statistic. It's really tough to retain all that stuff just when we're in chapter 1, but I'd say work hard on it because it's all over the book. These are just the basic things we have to get out of the way in chapter 1 because we're going to be working with them quite a lot. Also, I want to mention that this is really very rare. When we get a figure like 52% from a study, it's almost always going to be a statistic unless something special happened, like we took a census. Rarely do we know what the actual parameter values are. Let me add just one extra note here. These are typically unknown. So our situation, example 2, is a very rare kind of situation. Well, any questions, folks, on example 2 whatsoever? Okay, let's go off to other information about actually selecting data for beyond parameter and statistics. There's a lot of different ways that we can select data. And in our course, really all of statistics, some designs are better than others. And a golden standard for a really great way to get data in an observational study is the so-called simple random sample. Because this is just an introductory text on statistics, a lot of the data that we're going to be working with is assumed to be a simple random sample. But the more and more statistics you take, the more you'll realize That's not always the case. There's other sampling methods. And sometimes it's not even clear if the way they got the data was random. Sometimes people just try to argue and justify it. So what we're trying to do here is just make us aware of different sampling designs. For a simple random sample of size n, here's what has to happen. It is a sample selected from a population in such a way that every different possible sample of this size n has an equal chance of being selected. And the further I read that sentence, the more confused I kind of get. That is a very precise statement. So say, for example, our population interest is us, everyone right here in class today. If I want to select a simple random sample of, say, 7 different people, first thing I need to do is build up a sampling frame. I need a list of everyone in class if that's my population. From that sampling frame, I can devise a way to select at random, and not just at random, through a simple random sample, a group of 7. And every possible group of 7 has an equal chance of emerging. Well, those are all just words. Let's actually see it in action. Let's actually conduct our simple random sample just to see how would it go. Any questions or comments first? Okay, and notice one weird feature about my notes I mentioned last class. This is not a numbered example, which means it may not be a direct question you might see at WebAssign. It's more us just trying to illustrate the definition, try to get it some meaning behind it, try to give our brain just a little bit of extra traction on what's going on with these two definitions. So what we're about to do down here is not necessarily a problem I'm going to ask on a quiz or an exam. It's more of a demonstration, just to see how to get a simple random sample. Usually technology is highly, highly encouraged. I'll use Excel since it's easily accessed for us. I'm not going to use Excel a lot, just here and there. It's always going to be for illustrative purposes like we're doing right now. So don't feel like you have to have a computer with Excel running for this course. So like we mentioned, let me zoom in on this a little bit more. First thing I want is, no rows, a sampling frame. So here I would list every student in the class today, but for privacy matters, I'll just associate a number with everyone. Let's see, how many do we have today? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. We have 18 people. Let me know if I miscounted, if you're faster at that than me. So each one of these digits represents someone in class. Who it represents is not as important, but I was going left to right, top to bottom. It's important to you. All I'm doing here is just making sure that these digits stay put. Oh dear, I don't want to save it though. So we've got it, folks. That's our sampling frame. If you were doing a random sample from Idaho residents or anything like that, you would have to do the same kind of work. Now our goal here is select 7 students at random. So I need to decide who of the 7 or the 18 are going to be part of the 7 to be selected. To do that, randomization is always key. If we're not doing this, selecting at random, then all of our data is biased and heavily tainted. So here's the randomization I'm going to use. Going equals rand, not something you have to memorize for this course, but just so you know what I'm doing, is going to select a random number between 0 and 1. So this person gets the number 0.25891. Oddly, anytime I do something like type a letter, that number is going to update and change. Now everyone has a random number. There they are. And now every single one of these digits was assigned completely at random. Random is kind of a philosophical word. They're pseudo-random if you're curious, but they're random enough for our purposes. What I'm going to do next is select everything here and sort. I'm going to sort from the lowest digit to highest digit, knowing that these are all completely random. And I'll just take the first 7 that appear after sorting. So I'll go over here, data, sort on cell values. Let's go with column B that has our random digits here from smallest to largest. And here's our updated list. So I have 1, 2, 3, 4, 5, 6. Well, let me count those better. 1, 2, 3, 4, 5, 6, 7. Those students there are part of my simple random sample. And any grouping of 7 students has the same chance of being part of my sample. There's no bias here. And so if there's no bias, whatever data I'm collecting on this, it can be considered much more trustworthy. So I'll put here, the random sample is students with numbers. They are 4, 10, 18, 13, 14, 15, 17. Those like Powerball numbers for some reason. And that's one way to do a simple random sample. There are many different ways to do it depending on what software you're using. My purpose here is just to show you how you would actually do it if you had to. Any questions or comments about that so far? Okay. Oh, I want to get the evil looking red dot out of there first. I'm just going to throw it into the notes here. Just show what the result was of that. You can always go back to the video to see it built step by step. But again, our purpose here was just understanding simple random sample and what we mean by sampling frame. Any questions or comments about that little exercise here? Okay, so there are ways to achieve this, but sometimes a simple random sample is extremely difficult. Say, for example, you are studying fish. Maybe it's going to be all fish in a certain lake in Idaho. How would you build a sampling frame? You need to have other sampling methods working for you because identifying every single fish in a lake is probably going to kill an awful lot of them after you start tagging them or whatever you have to do. So there has to be other sampling designs. Our book tends to focus on this one being the introductory course, however. Well, we're not quite done with these notes, but one of the things I'm going to try to do this semester, which is kind of tough with a 50-minute class, is not get halfway into the problem and then say, I'm sorry, we're out of time. We'll pick this up later on. So this might be a good ending spot for us. We'll start talking about ways to taint the data, biases of different sorts. But any questions or comments, folks? Yeah, go ahead.
On the last, I think it was 1.2 at the very top, I saw that the writing that you did today was actually left over, like on our notes. And does that happen when you do that on all of them?
I'll be doing that on all the notes, yes. So this one, yeah, it stopped right here because that's where we left off last class. These notes here on Moodle, they're going to be completely fleshed out. And the section 1.3 notes, well, they're only going to go to here. And then once they're completed, I'll have the whole set uploaded. Other questions at the moment? Okay, well, another thing I want to mention is my schedule is a little bit weird. I teach this class from 6 to 6:50, and then I go 7 to 8:07 on Monday, Wednesday, and Thursday. Still learning my schedule. That means Tuesday is special. At 6:50, I don't have another class coming in. This is my last one for the night. So if you have questions or anything you want to discuss, web assign issues, things like that, I am available after class on Tuesdays, as well as the other days, but you'd have to wait till 8:07, which is a long way to after class. Well, have a great night, folks. If you have questions, feel free to stick around. I'll be happy to help. Otherwise, I'll see you all on Wednesday.